Okay, so it's obvious that I write way too big, but that's okay. We are going to plow through these notes because they took a long time to create, and again, they will be better. So first thing we need to do is go back to page 1 and review what coterminal means. So the very first page, you drew two angles. One was a 45-degree angle. The other one was a 405-degree angle. Which went all the way around, and then there's that 360 for all the way around the circle, plus the additional 45. So these two angles are coterminal. Their initial side, the starting side, is in the same place, and that ending side, that terminal side, is in the same place. So coterminal angles are always 360 degrees apart, or a multiple of 360. So we're going to say 360 times n apart, or 2 pi times n apart. And I'm going to go ahead and make that not look like an x. All right. So for problem number 10A, 415 degrees, we want the smallest possible angle, so we want the smallest positive angle. So I'm going to go ahead and subtract 360 from 415, and we get that a 55-degree angle is coterminal with our 415-degree angle. B, we start with 730. That's a whole lot bigger than 360. And so if we think about it, 360 times 2 is 720. That looks a little better. We're going to subtract 720 off. That's 2 times 360. Same thing as if we would have subtracted 360 twice. And we get that 730 is coterminal with a 10-degree angle. For C, we've got negative 1500 degrees. So this time I still want to get up to the positive. I'm going to add 720 at a time. If I add 720 to that negative 1500, I get negative 780. I'm going to add another 720. I'm at negative 60. And so from here, if I add 360, I get positive 300 degrees. So our negative 1500 degree angle is going to end up at the same place that an angle of positive 300 degrees is. Okay? The next set, problem 11. We are looking at these in terms of radians. So I'm going to create a new page here. 11, we want an angle coterminal with 13 pi over 6. And so here's the thing. We have to either add or subtract 2 pi. So here, I'm going to subtract 2 pi. I need to have a common denominator to be able to do that. So I got 13 pi over 6 minus 12 pi over 6. Sorry, I multiplied 6 times 2 to get that 12 in the numerator. I get pi over 6, which is the coterminal angle for that 13 pi over 6. So for B, we have negative 3 pi over 10. This is negative, so I'm adding 2 pi. Negative 3 pi over 10 plus 20 pi over 10. And I'm getting a positive 17 pi over 10. Our last one, C. C says 10 pi over 3. That's positive. It's bigger than 2 pi, so I'm subtracting off 2 pi. I get 10 pi over 3 minus 6 pi over 3, and we get 4 pi over 3. So much better with all that space to write in. Okay, back to the notes real quick. Those are our coterminal angles. Again, they wanted the smallest possible angle, and so we found the one that was closest to 0. So the next part here that we're going to look at, we've got arc length, and this is laid out for you. When we talk about arc length, what we're looking for is part of a circle. So we want part of the whole. Page 1, we talked about the circumference of a circle. So we can take a look at this angle part cut out of the 2 pi all the way around. So we've got our circumference of a circle. That's 2 times pi times r. It changes as the radius changes. The part of the circle that we're cutting out is pi over 2 pi. That's the angle all the way around. As we look at this, we get pieces that cancel. The pi's cancel, the 2's cancel, and that is how we end up with an arc length of r times theta. Pretty straightforward. What you're going to want to do is just remember this formula here for how to find arc length, knowing where it's coming from. Same thing with the area of a sector. We know that the area of a circle is pi r squared. Again, we're taking a look at only part of the circle. We want our angle theta out of 2 pi. The 2 pi takes us all the way around. Again, we have pieces that cancel. Just the pi here, actually. And we end up with 1 over 2 times theta times r squared. So when it comes to finding area of a sector, this is the formula you're going to want to remember. You're going to notice as we go through some of the example problems that they're not laid out super straightforward, and so you kind of have to play around with what you have and what you're trying to get to figure out what you need to use.